Good evening, children. Welcome to Akshara IT Foundation. This is Srinivas, your maths faculty. Right. Coming to the today's topic. So we are in the number system. Between the exercise we are being here. So up to previous class, I hope everyone got all type of problems, and I hope everyone is doing the revision based on that definitions and the formulas which are using in these previous problems. Okay? Yeah. Now shall we go to the today's class? Shall we go through the problems? Very good. Yeah. I hope we have completed up to 11 problems, right? So nothing but while you are observing the previous class, I discussed the 11th problem before and 10th problem later, because this alter is different from my book. Okay, that's why I have taken like that. So it doesn't matter. Now coming to the today's class, 12th problem here, the number of natural numbers up to 150. Natural numbers are nothing but 1, 2, 3 for counting numbers, no? So up to 150 numbers if you take, that are divisible by 7. So from 1 to 150, how many numbers are divisible by 7? Nothing but how many multiples of 7 are there? How many multiples of 7? Now we are simply dividing the 150 with 7, then we know how many multiples are there, right? Yeah, 7 tables, 7 2s 14, 1 remainder, 0, 7 ones, 3 is the remainder, so that means up to 21 multiples are there and with some remainder. So what is the last multiple here? We can subtract this remainder from 150, we will get 147. This is the last number which is multiple by 7 from 1 to 150. Okay, na? We are just doing the division with 7 table. Then we can find the number of natural numbers which are divisible by 7. Okay, na? Very easy question and direct question too. So such type of model is already somewhat tricky. Question based on this type of divisibilities. Okay, will be coming soon. In this in today's class only. Okay. Now coming to the third question, total number of factors. Number of factors of 36. How to find the number of factors? Yeah. Regular prime factorization method we are doing. Yeah, 2 table here 18, again 2 table 9 times, 3 3s, 3 1s. While doing the prime factorization, we should take only the prime numbers, okay? So 36 can be expressed as 2 square into 3 square. 2 square into 3 square, because 2 is presenting here 2 times and 3 is presenting 3 times. So 36 is nothing but 2 into 2 into 3 into 3. 2 square into 3 square. Now number of divisors or divisors of a number is equals to, what is the formula, children? n1 plus 1 into n2 plus 1. n1 plus 1 into n2 plus 1. Nothing but n1 and 2 are coefficients of the prime numbers. Sorry, not coefficients, sorry, exponents of the prime numbers. What is the exponent for prime number 2? It is also 2. So 2 plus 1. Exponent of the prime number 3 is 2. Again 2 plus 1. So 2 plus 1 is 3, 2 plus 1 is 3. 3 3 is 9. So total number of factors or total number of divisors all are same. Answer 3. Third option. Okay. Just studied a prime factorization and I applied the formula. Or else we are having another method also for 36, 1 table, 2 table, like each and every table we have to check and we have to count total number of divisors or factors. Okay. it is better. For small numbers is regular method is okay, but very large numbers we have to apply the formula. It is very useful for us. Next, number of odd factors. Odd factors of 90. Same process. Yeah, first prime number 2 table 45 times. Next, 3 you can take or 5 you can take. 5 table, how many times? Yes, 9 times. 3 table, 3 times, 3 table, 1. So the prime factors of 90 equals to 2 into 3 square into 5. This is regular prime factorization. Its prime factorization is unique for every number, right? Now, coming to the prime factorization, see, 2 is presenting here. 2 is one of the prime number. 3 is a prime number. 5 is a prime number. But in these 3 prime numbers, only 3 and 5 are odd primes. Only 3 and 5 are odd primes. They are asking about odd factors only, no? Now we have to consider only exponents of odd primes. Therefore, odd factors, same process. Odd factors equals to, what is the exponent of 3? Is 2. So 2 plus 1 into. Second odd factor is 5. 5 power nothing here, you can see that means 1. 1 plus 1. So 2 plus 1, 3. 1 plus 1, 2. 3 to 6. 6 odd factors. Very easy problem. Such type of models you already got it in your previous exercises, right? Okay, na? Yeah. So based on that factors and all, factors and divisors, until then we got 3 or 4 formulas, nothing but number of divisors, this one only, number of divisors, sum of divisors and product of divisors. Only 3 formulas we discussed until then, and today we have to discuss number of ways how a number can be expressed as product of 2 numbers. Okay, that is also we are discussing today. Let us go to the next problem. Yeah, problem number 15. The number of numbers between 11 and 111. 11 and 111 that are multiples of both 2 and 5. Multiples of both 2 and 5. That means we have to choose some numbers that should come in 2 table and 5 table as well. 2 table, 5 table together coming in a same number is nothing but 10 table. So we can identify the numbers which are between 11 and 111. We are checking the multiples of 10 between 11 and 111. So simply, as we discussed in previous problem, how we are finding the multiples of 7? Directly we are dividing with 7, no? Here I am dividing with 10. Okay, because clearly given that number should come in both 2 and 5. They should come in both 2 table and 5 table, nothing but 10 table. So 10 11s are 110. So 11 numbers are there between them, but here I have taken up to 111, means from first number to 111 I have checked. But here asked about 11 to 111. That means up to 11 how many numbers are there which are divisible by 10 table? 10 ones are 10. Okay, now this one we should not consider that. So 11 minus 1, 10. There are 10 numbers which are divisible by both 2 and 5. In simple general way also we can find, see, 10 table is nothing but 11 after 10 table. Which number will come? 20. Next 30, 40, 50, 60, 70, 80, 90, 100 and 110. These are the numbers which will exactly divisible by both 2 and 5 between 11 and 111. Between 11 and 111. Check how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay now. Why I am saying this method? Instead of giving 11 to 111, if it is given 300 to 999, then for counting us it will take some time. So simply we can divide like this. Okay na? First we have to divide with 10 table the larger number. The larger number means from 1 to that number we are counting. Okay na? From that smaller number we have to divide, subtract both the quotients. We will get the required answer. Okay? Shall I go to the next? Coming to the next question. The minimum value of this expression. Minimum value of this expression, what is that expression? Modulus of 17x minus 8 minus 9. What is the minimum value of this expression? We have 4 options, 1, 2, 3 and 4. 4 options. Let us substitute each option and let us find the minimum value. Now I am going to the first option. In the place of x I am substituting 0. Okay na? So 17 into 0 is 17. This part will become 0. And what is being here? Minus 8 in modulus. In modulus minus 8 also gives the plus 8. Very good. Here 8 minus 9 is minus 1. So one of the answer is minus 1. Okay. So while you are substituting 0, we are getting the minimum value is minus 1. Coming to the second one. In the place of x, we have to substitute 8 by 17. Okay, 8 by 17 minus 8 minus 9. Numerator 17, denominator 17 cancel. 8 minus 8 is 0. So modulus of 0 is nothing but 0 only. Still what is remaining? Minus 9. So from the two options, my second option will give the less answer because minus 9 is smaller than minus 1. Okay na? Now checking for third option. Minus 9. 17 in the place of minus 9. Minus 8. (17) into minus 9. This will be whatever it is. 17 nines or something will come. Okay. That value subtract from 8. Both are negative values now. Inside negative answer will come. Whatever the negative answer, it will give only positive now according to the modulus. So more than 100 will come. So according to these two options, third option is more. You are not considering that. Last option. What is the last option? Well, you are substituting 1 in the place of x. 17 ones are 17. 17 minus 8. How much? Yeah. 17 minus 8 is 9. 9 minus 9, 0. So among all the options, we are getting the least value at 2. Okay na? Minus 9 is lesser than among all. Okay na? That means we have maximum chances to try to get the modulus value 0. Maximum we have to try to get the modulus of value 0. Then it will give the minimum value. Okay, because outside is negative number is there. Next. Yeah. Before we discuss that, see that number of numbers between 333 and 666 divisible by 5. Between numbers we have to find it. Same process. First larger number. If you consider the larger number, how many numbers between them are divisible by 5? Now I am dividing with 5 table. 5 13s, 65. 1 remainder. 6 again. 5 3s are 15. So how many are there? Overall 133. That means from the natural number 1 to 666, there are 133 multiples of 5. 133 multiples of 5. But we don't want up to 333. We don't want up to 333. So divide 333 also with 5. 5 6 are 30. Again 33. 5 6 are 30. How many are there? 66. 66. So we have up to 133, up to 666, there are 133 multiples of. Okay. So luckily here no need to take -1 here, because 133 and 66 numbers which are, that means how many numbers are divisible by 5? Here 66 numbers here. That means before 33 we have 66 numbers. Up to 666 we have 133 numbers. Directly we can subtract like previous problem. Okay na? So what is the answer here? 67. So when we have to use the -1, for example 666 is there. Instead of 666, if it is given 665, that number also will be divisible by 5, because it will be end with 5 table, no? In such cases we have to use -1. Okay, na? Right. That means that number we are eliminating. Next question. Yeah, coming to this, if 2a minus 9 equals to b plus a, then the value of modulus of a minus b, b minus a value is how much? So I am taking the given equation, 2a minus 9 equals to b plus a. Try to bring all the variables one side and numbers one side. All the variables one side, numbers one side. Okay, 2a, a is a variable. This -9 transpose this side becomes +9. And b plus a both bring together this side, minus b minus a. Okay, that implies 2a minus a, this 2. 2a minus a gives a. This is minus b as it is. A minus b value I got 9. A minus b value I got 9. Let us take the required value a minus b in the set of modulus and b minus a. We have to find this value. If a minus b value is 9, what about b minus a value? A minus b value is 9. B minus a value is -9. Simply we are just multiplying with minus symbol both sides. A minus b is 9 means b minus a. Reverse order we are taking, then the symbol of 9 will be negative. Okay, substitute the value here. A minus b value how much? Positive 9. Plus b minus a value how much? Negative 9. So positive 9 and negative 9. So plus into minus becomes minus. So 9 minus 9, 0. So modulus of 0 is nothing but 0. So option is 3. Okay, na? First, with the given equation, we found the value of a minus b, it is 9. But in the question, we need b minus a also. So if a minus b value is 9, from this equation, we can say that b minus a value is -9. Because just we are changing the position of the first two numbers. Means given numbers A and B. Clear? Product of divisors. Product we should find. So until then we have discussed number of divisors, sum of divisors and product of divisors in our previous class. Formula, the number power half of the divisors, right? So with the using of that formula, we have to find the divisors of 7056. 7056. Before that, we have to find the prime factors of 7056 because we should find number of divisors. Okay, na? Yeah, try to find it, children. Number of divisors. Last digit is even number. We can use 2 table. 2 35s are 70, 2 2s are 4, 2 8s. Again 2 table we can take. 2 1s, 2 7s, 2 6s are, 2 4s are. 2 8s are, 2 8s are, 2 2s are. Again 2 table, 2 4s, 2 4s, 2 1s. Now 3 table will come. 3 1s, 3 4s, 3 7s. Again 3 table or directly you can take 7 table. 7 21s are. Again 7 table, 7 3s, 3 1s. So 7056 can be expressed as how many 2's? 1, 2, 3, 4. 4. So 2 power 4. Its prime factorization is 2 power 4 into 3's are 2. 3 into 3 is nothing but 3 square. Next, what is the extra? Another factor is 7. That is also being 2 times. 7 square. Now let the number of divisors or divisors of a number equals to, just we are using the exponents. I am just writing direct answer. 4 plus 1 5, 2 plus 1 3 and 2 plus 1 3. Okay. How many are there total? Okay, na? 9 5s are 45. Okay. Now coming to options. According to the number of divisors formula, number power divisors by 2. That equals to 7056 power. Number of divisors are 45 whole by 2. But check the answer. All are given in the powers of 84. All are given in the powers of 84. Simply 7056 is nothing but 84 square. 84 84s are 7056. Now we are writing 7056 as 84 square and whole power 45 by 2. Both exponents cancel. So we have remains 84 power 45. 84 power 45. Answer is 3. Did you understand this? This is the formula we are using for product of divisors. Okay? Yeah, next question. The number of ways that 576 can be expressed as the product of two distinct factors. Here you should remember that two distinct factors for number of ways. Here this one. So remember this formula, children. So number of ways for arranging the given number or expressing the given number as product of two distinct ways or product of two factors. Number of ways to express a number as product of two factors. Product of two factors. The formula is number of factors or number of divisors plus 1 by 2. Number of divisors plus 1 by 2. When we have to use this formula, expressing as product of two factors. One more formula also is there. Here given that clearly two distinct factors. For distinct factors, just there is a small change in the formula, that is number of factors minus 1 by 2. Okay, na? Directly asking about the two factors is number of factors plus 1 by 2. Distinct factors means number of factors minus 1 by 2. So the question is asking about the two distinct factors now. So we have to use this formula. So before that, D of n, nothing but divisors of a number or number of factors. To find the number of factors, we have to do the prime factorization method, right? So let us find the prime factors first. 576. Find the prime factors. 2 table, 2 2s, 2 8s, 2 8s. Again 2 table 144 times. 72, 36, 18, 9. 9 is nothing but 3 into 3, 3 square. So overall 576 is nothing but 1, 2, 3, 4, 5, 6. 2 power 6 into 3 square. So number of divisors 6 plus 1 7 and 2 plus 1 3. So total 21. Substitute in this formula. That is equals to number of distinct factors. Number of factors are 21. 21 minus 1 by 2. 21 minus 1 is 20. 20 by 2 is 10. Okay. This formula is very, very important. How we express 576 or any number as product of two factors. Yes, product of two factors. Right. The sum of three prime numbers is 100. 3 prime numbers is 100. If one of them is exceeds another by 36, then one of the number is, we have to find one of the number among the 3 prime numbers. We don't know the 3 prime numbers, but there is a clue is given for that. One of them exceeds another by 36. Now I am taking X, Y, Z, 3 prime numbers. I don't know 3 of them, but clearly given that one of them is exceeds another by 36. If one is exceed, one is X, second one we can consider as X plus 36. Am I right? Because one is exceeds. Exceeds is nothing but getting more. This number is 36 more the first number. So first number X, second number we can take it as X plus 36. Okay. Now, third one I can take it as Y. Okay. So sum of 3 prime numbers is 100. So add all of them. X plus 36 plus Y equals to 100. Now plus 36 transpose that side. Here 2x plus y equals to 100 minus 36. What is the value of 100 minus 36? 64. Okay, na? Now, here you should use the basic concept, children, because if you take 3 prime numbers, their sum is even number. 100 is nothing but even number, right? Okay. So, well, compare it to the prime factors. 2 is only the even number and remaining all odd numbers. And in your 7th class or 6th class, you will learn that sum of any 2 even numbers is even number. Sum of any 2 odd numbers also even number. one even number and one odd number. One even number and one odd number will give you odd number. But in the three numbers, two should be odd because only one have the chance of even prime, that is 2. Remaining two should be obviously odd numbers, odd primes. So with that concept, y can be 2. Y can be 2 because x we cannot take it as 2. If x is 2, then what is the second number? X plus 36. 38 is not a prime number. X is prime number but second number is not a prime number. Here x cannot be prime. Y, that means, sorry, x cannot be 2. X cannot be 2. So we are taking y value is 2. Now 2x equals to 64 minus 2 is nothing but 62, and x value is 62 by 2, nothing but 31. So if x value 31, what is x plus 36? 31 plus 36 is 67. Y value is 2. So according to the question, we have the one of the number is 67 because we don't have 31 here. 31 is not given, 2 is not given. So only one and only option for us is 67. This concept, did you understand this concept? Sum of two even numbers. Here we are using that sum of two odd numbers. These two becomes even and this is also even. Like that. Yeah, last 5 minutes for today's class. Now coming to the 22nd. Okay, 1 second. Yeah, coming to the 22nd question. Sum of the factors. Second formula. What is that formula? P1 power n1 plus 1 minus 1 by P1 minus 1. 5 2s, 5 7s. Now 3 table 9 times, 3 table 3 times and 3 table 1. So nothing but the prime factors are 2 power 1 into 5 power 1 into 3 power 3. So total number of divisors. So you no need to find the total number of divisors. First prime is 2, second prime number 3, third prime number is 5. 3 times we have to substitute the formula. So P1 is nothing but 2. 2 power how much? 1. According to the formula 1 plus 1, 2. Minus 1 by 2 minus 1. Now here 5, second one. So P2 means prime number only, second prime number. N2 means its exponent 1. Again 1 plus 1, 2. Minus 1 by 5 minus 1. And third one, 3. 3 power exponent is 3. 3 plus 1, 4. 4 minus 1 by 3 minus 1. Okay. 2 square value 4. 4 minus 1, 3. 3 by 1 into first one answer. 5 square value 25. 25 minus 1 is 24. 24 by 4. 5 minus 1 is 4. 3 power 4. 3 power 4. 3 into 3 into like that 81. 81 minus 1 is 80. 3 minus 1 is 2. Now after cancellation, 4 2's 8. 8 in 80 10 times. Okay, now? Clear? Yeah. 3 24s are 72. 72 into 10, 720. Answer is 720. Sum of factors or sum of divisors, both are same. Okay? Still how many questions we have? 20. Still 3 questions are there. Okay, 23. The unit digit in the product of first 50 odd natural numbers. Very easy, children. Let us take first 50 numbers. Before that, first odd number 1, second odd number 3, third odd number is 5. Up to here is enough. 1 3 are 3, 3 5 is 15. 15 means units place is 5. If you multiply any odd number with 5, it always gives unit digit is 5 only. You can check. If you want, you can check. 5 multiply with any odd number, it always gives only unit place is 5. So what is the units place here? Because these are all odd numbers only, no? Odd natural numbers. When 5 starts, here onwards all will gives the last digit is 5. These also completed. Now we have, number of ways of expressing. This question we already discussed that. Two formulas I gave, no? Distinct or same, two factors. This one you try. Try this 24th problem and 25th problem. The number of positive integers, this will take some time. So thank you one and all.